Alrighty, in this video we will be doing exercises 33 and 34 from section 1.1 of Stewart's Calculus, 7th edition, early Transcendentals. And in questions 31 through 37, it says to find the domain of the function, and in 33 we are given that the function f of t, not x, is equal to the cubed root, alright, of 2t minus 1. Alright, well, first of all, what does the graph of the cubed root function look like? It looks like this. Well, almost. Hold on. There we go. It's kind of like that. Yeah. So what does this tell us? This tells us automatically that its domain goes from positive infinity to negative infinity, all real numbers. So no matter what adjustments you make under the radical or outside of the radical, well, not necessarily, but whatever adjustments you make inside the radical, unless you make it a quotient, the domain will always be all real numbers. A fancy little r. I always do # for numbers, and that's our domain. Nice brown. All right. 34. Is little g of t is equal to square root 3 minus t minus square root 2 plus t. Okay, so what can we not do underneath the square root radical? Oops. Right here in particular? Well, t has to be less than or equal to 3, right? Because we can't have a negative under the radical, the square root. So under here, t has to be less than or equal to 3, because 3 minus 3 is 0. And we can do square root of 0, that's 0. But anything greater than 3 is a negative number, we can't take the square root of a negative number. Here, what is the condition, the limit, or the condition, I think is a better word. Well, t cannot be less than or equal to negative 2. So t has to be greater than or equal to negative 2. Right? Because if you plug in negative 2, you get 2 minus 2, and square root of that is 0. Okay? But if you go lower than that, if you go negative 3 here for t, you get 2 minus 3, which is negative 1, and you can't take the square root of a negative number. This minus sign doesn't really matter in determining the domain here, but so we have to exclude all these values from our domain. So let's draw a number line just to see what this kind of looks like. Okay, we have, let's plot 0 in the middle, good old 0. 1, 2, 3. 1, negative 1, negative 2. Okay, so the domain is less than or equal to negative 3. So less than or equal to negative 3 and greater than or equal to negative 2. So this is the domain. Okay, and if you graph it, I graphed it on my graphing calculator, and it came out looking like this. If I get the y coordinates right, it was something like and that was it, and I was like, whoa. Actually, let me see if I could pull it up again. Oh, no, it goes through the origin. Yeah, the graph is like, and I was like, whoa, That's a funky domain. So it stops at -2 here, and it stops, continues no further past 3 on the graph. Okay. So the domain for this, in interval notation, the domain is inclusive, right? -2 to 3. It is simple as that. Alright, so that's question 33 and 34 of section 1.1. Stay tuned for more exercises.